Hi all, it's Professor S here. So for this slide presentation, this video, I'm going to talk about an overview of Chapter 1 from the textbooks from statics. Of course, this is not, uh, this is an overview, so don't expect there to, you're going to have to read the uh, chapter, and you're going to have to go through the other lecture material. So I'm just going to kind of get into the high points. There's not a lot of material from Chapter 1. As we get started, I usually talk about this in the first class, and it's just something to think about as we get started on the semester and on this first chapter. This is pretty much consistent across the country. Approximately 50% of the people that take statics for their first time fail. So what I usually do is have people break into groups of 2 to 4 and brainstorm some strategies to think about what are you going to do differently so that you're not in that 50% that fail. So obviously this is a video, it's not interactive, but it's something to think about as we start talking about this first chapter. What are you going to do to make sure that you're not one of those that is going to be in that 50%? So chapter 1 essentially deals with units, doing some calculations, and coming up with a procedure to solve problems. This is stuff that you would have seen in physics along the way, because physics obviously is a prereq for stats. So part of the chapter talks about these different branches of physics, um, different types of mechanics. You can see rigid bodies, things that don't change shape, that don't deform. Statics and dynamics fall out of that. I've mentioned in my introduction video, and you might have heard me say it before, that I'm an electrical engineer by background. So electrical engineers do take statics, just like mechanical engineers have to take a circuits course. I've never taken dynamics because I went electrical engineering. That's all my degrees throughout the way. You will have to take some fluids classes. You take some material science classes, all that as if you're going for mechanical engineering. So Newton has 3 laws, right? The one that is most important for statics is this equilibrium idea. So the whole basis of statics that we'll be discussing for this entire semester is there's a body and there are forces acting upon that body. And if that body is in equilibrium, those forces essentially cancel each other out. So in this particular case, right, there's a particle in the middle. That particle is at rest, hence statics. Right, dynamics stuff moves, but in statics things don't move. Right, the forces, those 3 forces are acting upon it. If it is in equilibrium and it is in static equilibrium, then the resultant of those 3 forces added together would become 0. Right, you deal with velocity and acceleration when you get into dynamics, not so in statics. So the other part of chapter 1 are these conversions. Uh, so mass and weight, the combination of mass and weight, right? Weight is mass being acted upon over gravity. So that is measured in newtons, and weight and mass is measured in kilograms or grams, depending in the metric system. The one nice thing about English units is pounds force and pounds mass are exactly the same on Earth, right? They're different in other parts of if we went to Mars or we went to the moon, pounds force and pounds mass would be different, but on Earth they're the same. So being able to convert between mass and weight, to be able to convert between English and metric units doesn't happen too often, and I would not ask you to do a problem that way. So either the problem will be all in metric units or all in English units. There would be no mix of the two. Significant figures, that always gets asked. You're going to be submitting all your work via Mastering Engineering. And you'll see with the problems they ask you to submit your answer with so many significant digits. So make sure you follow the directions of what they say, because you can get the problem wrong if you don't follow what they actually tell you to do. The other thing, this comes up more in circuits than it does in mechanics, right? But there are these engineering units that correspond to exponential numbers, each power of 3. So the base 10 to the 0 power, essentially 10 to the 3rd, the 6 to 9, and minus 3, minus 6, minus 9, all have this metric prefix and this engineering letter associated with it. It's good to know, but mega and kilo are probably the two that we'll see in this particular course. So this is actually a good thing to remember. If you can justify units, right? So this homogeneity in units essentially means that you have to have the same units on one side versus the other. If you don't remember formulas, but you remember to do unit cancellations, you can come up with any formula along the way. So bear that in mind. Make sure your units are going to cancel out and give you the right units for the answer, or your answer is going to be gibberish in that particular case. The consistency with rounding off, right? Typically, if it's say 5 or higher, you round up. So the 35.28 rounds up to 35.3. If it's less than 5, you round down. So we got the 0.03521 rounds to 0.0352. And again, there will be, in Mastering Engineering, they will say, give me 3 significant digits for the answer. So make sure you follow the directions. Having some sort of problem-solving strategy is great. This is the one that's obviously given in your textbook. As you can see, it's their slide. But typically what the problem-solving strategy should have, and this is where students sometimes will mess up, right? You get a big fancy scientific calculator and you spend a lot of money on it, and you would like that calculator. You like to push buttons on the calculator. That's essentially the last step. Right, the first step is actually to go through the problem and make sure you understand, can paraphrase the problem that's being asked. So make sure you are solving the correct problem. Right, come up with the plan of how you're going to get from the steps of what they're asking for to the end. Right, I think diagrams, some kind of diagrams, actually should probably be farther up. That probably comes in the interpret, in my opinion. Right? Some kind of sketch, some kind of diagram, so you can picture what it is you're going to solve. If you like this approach that's given in the textbook, great. If you don't, and you have your own approach, the key is to have a systematic approach to solving problems.